Hello dear friends, welcome to another session of our Plus 1 Computer Science class.
So far we have discussed about computer system organization, right? In that we have discussed the units of a computer, operating system and the interface, right? From today onwards we are move on to a different section, okay? You all know in our daily life we are making different kinds of decisions for doing a particular task, right? Like if you prepare in our exam very well, you can score high marks. You can attend the exam in a good manner, right? If you do like this, you will get like this. If you do this, you will get this. Like that, right? Decision making. Like that, in computer, different electronic circuits are working based on some decisions. Logical decisions. So today onwards we are starting a new chapter, Boolean Logic. That is mainly based on the decision on the binary values. Okay, so let us start our class.
Boolean algebra is the algebra of logic that deals with operations on variables that represents the values 0 and 1. So deals with the logic. Okay, logic means there will be some types of decision making, whether it will be 0 or 1. That is the value represented in Boolean algebra. It is the algebra of logic with operations on variables that represent the values 0 and 1. It is developed by the British mathematician George Boole. He is regarded as the father of Boolean algebra. In Boolean algebra, a true value is represented by 1 and a false value is represented by 0. So, the true value is represented by 1 and false value is represented by 0. It will be like yes or no or on or off condition. On is for 1 state and off is for 0 state. Statements which can give a true or false value are called logical statements. So, the logical statements are the statements which can give true or false value. The variables which can hold a 1 or 0 are called logical variables or Boolean variables. Can hold the value 1 and 0 are called logical variables or Boolean variables. Next is Boolean operators and logic gates. The operations performed on Boolean values. What are the Boolean values? 0 and 1. So, the operations performed on Boolean values are called Boolean operations. Okay, the operations which are performed on Boolean values are called Boolean operations. There are basically three logical operators are used in Boolean algebra. They are OR, that is denoted as logical addition, and logical multiplication, NOT, logical negation. These are the basic logical operators. A truth table. We have to learn about truth table. Truth table is a table that shows Boolean operations and their results. Okay. A truth table is a table that shows the Boolean operations and their results.
Going further, we will see how to represent the binary numbers corresponding to the decimal numbers. Okay, let us make a quick revision on this topic. Okay, first we have to write the positional weights of the binary numbers. The positional weights of binary numbers may be 1, 2, 4, 8, 16, 32, like that it will go. Okay, because 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, like that there is the positional weights involved in binary numbers. First we have to write 8, 4, 2, 1. Okay, this is the code. And we are going to represent the binary number corresponding to the decimal digit 0. For representing 0, we have to put 0 in all the positional weight. In the case of 8, 0, 4, 0, 2, 0, 1, 0. So, 0, 0, 0, 0. This is the representation of 0. In case of 1, we can represent 0, 0, 0, 1. In the place of positional weight 1, we have to put 1. And in case of 2, we have to put the positional weight 1 in the positional weight 2. 0, 0, 1, 0. In the case of 3, we can get the binary number by putting 1 in the place 2 and 1. Okay. Then can you say how we can represent the decimal number 4 in binary? Yes, we are going to put 1 in the fourth column. So 0, 1, 0, 0. Okay. Then we get 5 using 0, 1, 0, 1. By adding 4 and 1 we get 5, right? So we are going to put 1 in 0, 1, 0, 1. Okay. Like that we can do for the other numbers like 6, 7 up to 15. Okay. With the help of 4 this code 8421 we can make a combination up to 16 numbers. So 0 to 15 we can represent like this. But if we want to represent only 2 digits, we can use this type of code. Okay. Instead of 8421 we are simply using 21 and we are going to write the binary numbers for 2 digits. Okay, the first binary number is 0, 0. So we are putting 0 in all the 2's and 1's place. Okay. Then 1, 0, 1. Next 1, 0. Then 1, 1. These are corresponding to the decimal numbers 0, 1, 2 and 3. And if we want to proceed, we must at least note these binary numbers up to 0 to 3. 0, 0 for 0, 0, 1 for 1, 1, 0 for 2, 1, 1 for 3. Okay. Our topics. First, let us see what is logic gate. A logical gate is a physical device that can perform logical operations on one or more logical inputs and produces a single logical output. Okay, there are mainly 3 logical gates, basic logical gates. They are OR gate, AND gate and NOT gate. Okay, we have to learn about these gates. What are the 3 logical gates? AND, OR and NOT. These are basic logical gates. What is OR operator? OR operator performs logical addition and the symbol used for this operation is plus. Okay, this is the truth table. We are denoting the operations in a truth table and we are using the inputs A and B. And the combination of binary inputs are 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so in the case of OR operator, A plus B. OR operator is denoted with the plus sign. Okay, A plus B. So 0 plus 0, that means 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1 is 1. So if either of the input is 1, in the output is 1. Just remember, in case of OR operator, the output is 1 if either of the input is 1. Okay, the output is 0 if both the inputs are 0. It is read as A plus B or A or B. Okay, that is the case of OR operator. A plus B or A or B. Okay, the thing is, when both the inputs A and B are 0, the output A plus B is 0. If either of the inputs A and B is 0 or both inputs are 1, the output is 1. That is the main function of this OR operator. Okay. See, OR gate, the logic gate to implement the logical OR operation. Logical OR gate. You can see this is the representation of OR gate, the symbol of OR gate. We are giving 2 inputs A and B and this is the notation of this OR gate and the output is denoted as A plus B. Okay, we have learned about the truth table also. If you want to, you can see the electronic circuit of this OR gate. Consider the circuit given here. You can see there is a lamp is connected. Okay, and if you want to get on the lamp, we have to provide the inputs. A and B are 2 switches and OE is the bulb. Assume like that. For making the lamp on, okay, either we have to switch A or we can switch B, right? If you put either on of the switch, the lamp will get on, right? This is the purpose of OR gate. Okay, this is the working of OR gate. Either one of the input can be on, then the output will be on, or both the inputs can be on. That means both the switches can be on for making the lamp on. This is the working condition of OR gate. 3 input OR gate with truth table. We can make a notation for 3 input OR gate, and the output is denoted as A plus B plus C, where A, B, C are the 3 inputs which are given to the OR gate. We can see the truth table. We are using 3 inputs, okay, 0, 0, 0, 0, 0, 1, like that. The decimal numbers can be represented here, the binary numbers up to 0 to 7, okay, 0, 0 to 1, 1, 1, 7. The truth table, if any one of the inputs of A, B, C is 1, the output is 1, okay. If all the inputs of A, B, C are 1, then also the output is 1. If 2 inputs of A, B, C are 1, then also the output is 1. If all the inputs are 0 only, then the output is 0. That is a condition here for the 3 input OR gate. A plus B plus C. Okay, you can see the notation and you have to write the truth table and how to implement the OR operation in the case of 3 input OR gate. Next, we are going to see AND operator. The AND operator performs logical multiplication and the symbol used for this operation is dot. Okay, this is the truth table for AND operator. A dot B. The inputs are A and B. When either of the input is 0, the output is 0. We got the output as 1 when both of the inputs are 1. Otherwise, if either of the input is 0 or both inputs are 0, then the output is 0. So, we got 1 only when all the inputs are 1. That is the truth table here. 0, 0 means 0. 0, 1, 0. 1, 0, 0. 1, 1 means 1. Both inputs are 1, then the output is 1. This is the case of AND operator. The notation used for AND operator is dot notation. This is the logical multiplication operator. Okay, A dot B. You have to mention as A dot B and we have to provide the two binary input as 0, 0, 0, 1, 1, 0 and 1, 1. We have to write A dot B as A and B. Okay, AND gate. The logic gate used to implement logical AND operation is called logical AND gate. This is the symbol for AND gate. This symbol you must remember. Okay, AND gate. We have to give two inputs A and B. The notation is A dot B. We can see the working of AND gate with an electronic circuit. You can see in this electronic circuit, two switches A and B is used. The output is Y. That is denoted as the lamp on or not, on or off. When we put A switch, the lamp will not get on, right? When we put B switch, now also the lamp is in off condition. When we put both A and B switches, then the lamp Y is in on state. All the remaining conditions provide the lamp as off state. This is the electronic circuit for AND gate. I hope you understood thoroughly about this AND gate concept now. When both the inputs are on, then only the output will be in on state. Okay. When both the switches A and B are in on, then only the lamp will be in the on state. Otherwise, it will be in the off state. This is the electronic circuit for mentioning the AND gate. Okay. It is denoted as Y is equal to A dot B. This is called the Boolean expression. Input AND gate with truth table. We are using 3 inputs. 3 inputs to mention the AND gate. Here is the symbol for that. A, B, C are the inputs. The output is A dot B dot C. For the 3 inputs also, if all the inputs are 1, then only the output is 1. For all other cases, A dot B dot C is in which state? 0. Okay, for the combination of 0, 0, 0 to 1, 1, 1, if all the inputs are 1, then only the output is 1. If all the inputs are 0 or either of the input is 0, then the output is in 0. That is the case of 3 input AND gate. Here you can see the gate symbol and truth table. Now we are going to see the NOT operator. logical negation operator. Okay, the not operator performs logical negation and the symbol used for this operation is this over bar. On bar symbol over the output, that is the symbol of not operator. Okay, it is called logical negation. And this is the truth table, very simple. When input is 0, the output A complement. A complement is 1. When input is 1, A complement. Then negation of A is 0. Okay, inverter. It said inverting the input. 0 means 1. 1 means 0. Like that, the output we will get based on the input. It's a single input. Okay, single input gate. This is the truth table. You have to learn about this. And we will see the diagram also. Okay, then you will get clear idea. Expression A complement is read as A bar. Okay, A bar. Complement is also read as A dash. We can represent this as A complement is represented as A dash. We can say like A dash or A bar. Not gate is also called inverter. So A bar or A dash. Not gate. The logical gate to implement not operation is called logical not gate. The logical gate used to implement the not operation is called logical not gate. This is the symbol. One input is used and there is output A bar or A dash. If the input is 0, the not gate will give 1 output. And if the input is 1, the not gate will give the output as 0. Okay, so now you are all thorough about this Boolean algebra, the different logical operations and logical gates, right? Then can you say the answer of these questions? Define the term Boolean variable. Yes, you are right. The variables which can hold the values 0 and 1 are called Boolean variable or logical variable, right? A logic circuit is made up of individual units called gate. Okay. Name the logical operator or gate which gives high output if and only if all the inputs are high. What is the answer? Yes, AND gate, right? Define the term truth table. Truth table is a table which helps to implement the logical operations and results. An AND operation performs logical multiplication and an OR operation performs logical addition. Okay, draw the symbol of OR gate, that you know, right? I hope you understood thoroughly the concepts of OR operators, AND operators, NOT operators, and how to make the truth table, how to implement the logical gates, right? You are all now thorough, right, about these concepts. Please go through this video carefully and make a note of all the things we have learned today